Welcome everyone. Good evening. So today, welcome to this tutorial lecture on the NPTEL course Social Networks. So for today, what we'll be doing is we'll be revisiting week 4 assignments from previous iteration of this course, and in the tutorial session tomorrow, week 5 questions will be discussed. So without further waiting, let's get started. I'll share my screen. All right. So these are the week 4 questions from the 2022 version of this course. So is the screen visible to everyone? Uh, okay. All right. So let's get started. So coming to question 1. So Rahul became friends with Ram. Ram is an avid follower of cricket. Ram repeatedly took Rahul to watch cricket matches with him, and soon Rahul started following cricket. Which of the following accurately represents the following phenomenon? So you have four options: the selection, triadic closure, social influence, and focal closure. So let us explore the options one by one. So if it was a case of selection, then Rahul, wait, Ram is a cricket fan, and if Rahul was also a cricket fan, then this would result in selection if they became friends. So this is not what the question says. So we can rule out selection. Triadic closure, you need a third person. So here are only two people, Ram and Rahul. So triadic closure will also not happen. So to just to give, uh, yeah, option C is the correct answer. I'll come to that. So I'll explain each of the following for so that it's clear to everyone. So you're right, option C is the correct answer here. So if it was triadic closure, what would have meant was that Ram and Rahul are friends. They they let's say they became friends because of their common interest cricket, and Rahul is friend with someone else, let's say Raj. So in this case, Ram and Raj will also become friends. So that would be the case of triadic closure. So this is not the option here for this question. So social influence. So social influence means r- you become friends. So Ram and Rahul are friends, already friends, and then Ram influences Rahul. Ram influences Rahul by taking him to watch cricket matches regularly. So this is a case of social influence. So social influence is the right option here. And focal closure. So the option focal closure is not correct. Why? Is because suppose Ram and Rahul both met at a cricket academy or some cricket match, and then their friendship developed, then this would be focal closure. So focal closure is also not the right answer. So option C, social influence, is the right answer for this question. Okay, so let us move on to the next question. So Ram and Sham were two new entrants in KV Ropar. Their similarity measure was 0.005. They became friends on day 5. What is the most likely similarity measure right before they became friends? So now similarity measure is something between 0 to 1. 0 means least no similarity, No, and 1 means full similarity. Now, similarity could be uh, between anything. So, examples of similarity could be in common interests. This could be music, sports, food, anything. So it is a measure. Similarity is a measure of is a measure between 0 to 1. So 0 signifies no similarity, 1 signifies full similarity. So it is observed that we become friends. We become friends when uh, similarity increases. So just before becoming friends, our similarity increases. Now it is said that the similarity was 0.005. So after that, they became friends. So here the similarity measure would definitely be greater than 0.005. And like I told you, similarity measure lies between 0 and 1. So something that is greater than 0.005 and less than 1. So there is only one option of that kind. So option D, 0.01 is the correct answer. Uh, is there any doubt, or shall I move on to the next question then? All right, then let us proceed to the next question. Okay, coming to question 3. On an IIT campus, we observe that friendships among first year and second year students are greater than friendship within first year and second year students combined. What can we infer about the homophily of this network? So, what homophily is basically? Homophily is measure of connectedness within a group or community. So higher the homophily, it means that the community is tightly connected or the group is tightly connected. So it is said that you have first year students and you have second year students. It means if it was a highly if homophily was high, what it means is that the first years would be highly connected among themselves. So it would be something like this: all the first years are friends with each other, and similarly for the second year also same. So it would be a highly connected network. So now it is said that there are more uh, edges across. So first, there are more friendships among first year and second year than within. So let us say that the friendships within first year is F11, F22 denotes friendships within. So number of edges in first year and number of edges in second year, and F12 denote the edges across. So probability of an of selecting an across edge means across first year and second year is basically, so number of edges that we know from the given data between year 1 and year 2 are F12 by the total number of edges. So F11 that is within first year F12 that is across, and F22. So this is the probability. Now F11 plus F22 is less compared to F12, which means that F11 plus F22 plus F12 is less than 2 F12. Or if we take the reciprocal, 1 over F11 plus 1 F22 plus F12 is greater than 1 by 2 F12. Or if we multiply the numerator by F12 over F11 plus F22 plus F12, this would be greater than F12 by 2 F12, that is greater than half. So this probability is P. So this is uh, so we get that P is greater than half. So homophily is basically 1 minus P, that is less than 1 minus half, which would be equal to half. So the right answer would be that homophily is less than zero point 0.5, and it could be intuitively understood as well, because just by reading the statements you can see that the first years and second years are not well connected among themselves, and there are more friendships across first year and second year, which indicates a low homophily in the network. So a low homophily is usually less than zero point 0.5. So option D is the correct answer. Okay. Coming to question 4, if anyone had a doubt, you could ask, or you can ask at the end as well. So, coming to question 4, so Raghavan is a warden in the Ganga Hotel. He observes the following graph of the friendships of BTech and PhD students of Ganga Hotel. What is the homophily of the network? So, um, you have BTech students and PhD students. So if you count, there are 11 BTech and 11 PhD students as well. Now, in the comparing to the previous problem, here we did not know how many students were there in the first year and the second year. But here it's given that there are 11 students on the BTech side and 11 on the PhD side. Now, what actually homophily is basically the 1 minus uh, number of expect number of edges across by expected number of edges across. So so if we look at this expression, expected edges across, so what is the probability of, if we ask this question, probability of an edge being across? If you see that this is similar to a head and tail tossing, so so the probability of a head tail or a tail head occurring compared to a tail tail or a head head occurring, so this is half, and this is 1/4, and this is 1/4. A same situation will occur here. So this B, you have BTech students, so BTech and PhD, so it could be B1, P1, could be some if you draw random edges, so B1 represent a student from BTech and P1 denotes a student from PhD, so it could be B2, P5 and all such. So we are interested in how many of these are exist. So if we do some simple combinatorics, so we'll see that it would be uh, 11 cross 11. This many are of uh, either profile. So 11 cross 11 edges you will get, where the vertices are one from BTech, one from PhD. And what is the total number of edges that can exist is basically, if you consider that all the 22 nodes together, so it would be 22 into 21 uh, over 2. So this ratio is nearly half. So if you see, the probability of an edge being across is half. And what is the expected number of edges? So this would be half plus half, and would be half into 1, half into 1 into 1. So this many is the total number of edges present, present in the graph. So the expected number would be half into 16 edges are there in this graph if you see. So expected number of edges is 8. And so this ratio, the homophily, would turn out to be 1 minus uh, 4 by 8, which is half. So the right answer for this problem would be option A, half. So why couldn't we do the same analysis for the previous question is because we did not know how many students were there in the uh, first year and the second year. And in this graph, we have this additional information of how many students are there, and that's why we could find the expected number of edges. Else, if we don't have, so the best we can do is take the ratio of the across edges by the total number of edges present. Okay, so coming to question 5, uh, do, is does anyone have a doubt in question 4?
Sir, can you please repeat it again? I get confused some words.
Okay, so I'll repeat it. So Raghavan is a warden of the Ganga hostel. He observes the following graph of friendship of BTech and PhD students of Ganga hostel. So what is the homophily of the network? So homophily is basically 1 minus number of across edges present in this graph. Across means across from BTech to PhD. So across edges you can see are these 1, 2, 3, and 4 by expected number of edges. So if we were to find out expected number of edges, so first we need to find out probability of an edge being across. So what is the probability that an edge is across it? So this is what so if we pick all possible, how many possible edges there can exist is basically, if we consider all the 22 students, it would be 22 C2. So this many total number of edges can possibly exist, and how many across would be there would be 11 cross 11. So something of the type of B1, P1, B2, P2. These type of edges we are, by this type of edges we mean the cross edges. So what we do is, to find the probability, we take this ratio 11 into 11 by 11 22 into 21, that is 22 C2 by 2. And this ratio, if you evaluate, this is very nearly to half, if not exact. It won't be exactly half, but it is very close to half. So we can approximate that the probability of an edge being across is half. Now we find the expected edges across. So every edge that is existed in this graph, so the probability, let's say I take this edge, what is the probability of this edge being across? It's half. So similarly, what is the probability of this edge being across is half. So for every edge that is present in this graph, we add half into 1, half into 1. So there are 16 such edges. So the expected edges across would be half of 16, that is 8. And the homophily would turn out to be 1 minus number of edges across, which is 4 by 8. So that turns out to be half.
Sir, how 22 into 21 by 2?
This is the total number of edges that can exist in this network. So you have 11 nodes here, 11 nodes here, so total 22 nodes. So 22C2 is this 22 into 21 by 2. You this how will you how many total possible edges in the graph? Total possible edges, that is NC2. All right. So is this
Sir,
clear?
why I have to multiply one in each half?
Uh, can you repeat again? So, okay,
If
this
the
ex
expected age,
okay, so it would basically mean, so you consider any edge. So how you calculate the expectation? So you pick any edge, let's say between this I call this node 1 and node 2. You pick this edge. So it is not there in this graph present, right? But the edge, suppose it was, what is the probability that the edge that existed between 1 and 2 was an across edge is half. But since it is not there, we don't add it to the total number of edges. So it is 0. But if we consider this edge, let's say between 3 and 4, again the probability of this edge being an across edge is half. And how many edges are there between 3 and 4? 1. So if you do like this, you will end up with all it will basically be half into sum of edges. So basically it's the total number of edges, half into 16, that is 8. This is how expectation is calculated. So you find the probability of an event, and if that event is and if that event occurs, how many edges are across. So in the if between 1 and 2 there exists no edge, as we can see from the graph, so it is 0. Between 3 and 4 there exists one edge, so it can be 1. So like this, if you add up, this is how you get the expectation. All right, is it clear?
yes, sir.
Okay. So if we let us proceed on to the next question, which is question 5. So question 5 says, which of the following correctly depicts the probability of any two-person A and B being friends with respect to the number of common friends? So the first graph says that if your number of common friends increase, that you move along x-axis, so the chances of your becoming friends increases, and after a certain point it decreases. In option B it says that after a certain till a certain point it increases, then there is a dip, and after that there is again an increase in probability. In the option C it is seen that it linearly increases with the number of mutual friends, and option D says that mutual friends have no effect on a friend probability of a friendship existing between two people. So it has been seen from data analysis across the real world network that the right option is C. So what and it is more intuitive that the more the common friends you have, the more likely you are to become friends. So option C is the right answer, as has been observed from data. So okay, this was question 5. Let us move on to question 6. So the probability of John and Eva not being friends, given that they have a mutual common friend, is zero point 0.8. Probability of them being friends, given that they have 8 common friends. So let us call this probability as capital P. Capital P is basically 1 minus small p. Small p is probability that John and Eva are not friends despite having 8 common friends. So, how to find out P? So, we assume that this small p, let us consider q, small q, probability J and E are not friends but have one common friend. So P is basically q to the power 8 because we assume independent event, that uh, the presence of this common friends, that whether there is one common friend or two common friends, it is they are independent event. So probably they, by independence, the probabilities get multiplied, and hence we have to multiply it 8 times considering the 8 common friends, so it becomes q to the power 8. So capital P is 1 minus q to the power 8, which is 1 minus 0.8 to the power 8. This is around 0.83 if you solve it. So option A is the correct answer. Is this clear?
Q to the power 8. Can you explain again?
So we are assuming independent event. So uh, let's say the common friends of let's say the common friends be friends of John and Eva be C1, C2 till C8. Now, what is the probability that John is not friends with Eva, given that they have this common friend C1, C2, C8? This is basically by independence. We assume that these are independent. So, probability of John and Eva not being friends despite having C1 as a common friend into probability of John and Eva not being friends having C2 as common friend, and finally probability of John and Eva not being friends having C8 as a common friend. Now all these are Q's. So we are assuming they are independent identical event. So it is q to the power 8 because the q is multiplied 8 times. That's how you get q to the power 8. Is this clear?
Yes, sir.
Okay. So then let us proceed on to the next question. So coming to question 7. So question 7 says Ram and
Sorry, excuse me, sir.
yeah, go ahead.
So where are questions?
I am projecting them on the screen.
Actually, sir, it's not visible to me, sir.
Is this the problem with everyone? Let me check. So can someone confirm if they are also facing the same problem? I I checked my network connection. It's showing all right. So can any other student, are any of the other students facing the same issue with the screen not visible? So someone is saying it's visible. Ashwin, I think there is a problem on your side.
Actually, I have refreshed it also.
Okay.
So should I rejoin it?
Okay, you can try rejoining it once.
Okay, thank you. Sorry.
Okay. Okay. Coming to question 7. So we have Ram and Raghav, who are both part of the Royal Cricketing Club. They meet at the club and gradually become friends. So this phenomenon is known as, so this is basically option C, focal closure. So they, Ram and Raghav, uh, you have Royal Cricketing Club, let's call this RCC. So they both come here and then their friendship develop. So this is just like a foci closure. So this is the focus of their friendship. So this is option C is the correct answer. Uh, okay, proceeding to question 8. You have this graph. The increase in similarity in region B can be attributed to which of the following phenomena? So is it selection, social influence, triadic closure, and foci closure? So what happens is on the x-axis you have time, and here on y-axis you have the similarity measure. So what happens in this dotted line? They become friends after beyond this dotted line, and in region A they are not friends. So if you see, what happens is that just when they become friends, their similarity measure shows a steep rise. But they are asking us here in what happens in region B. So region B is they already become friends and then their similarity measure is rising. So this is a special case. This is the not a special case, but what we are seeing is social influence, that you become friends with them and then your similarities, y- you become more similar. So this is the case of social influence. So selection occurs before becoming friends. So this part is where selection occurs, and here social influence occurs. We cannot comment about triadic closure or focal closure because we don't have adequate information to comment on that. So for sure, we can say that it is a case of social influence. Okay. Coming to question 9. If the nodes in this graph represents players and edges between players represents friendship, then which of the following phenomenon might have resulted in the following network? So you have this cricket club network. So you have four options: foci closure, social influence, selection, and membership closure. So we cannot tell about these two because we need to understand how similarity measure varied. We do not have data on this. We no data. So we cannot comment whether this is for social influence or selection. So we would have needed this similarity measured data. Now coming to foci closure. So if you can see, take this node for example. So what's happening is that if you see the neighborhood nodes of this, so let's say this, they are all coming to incoming to this particular node, and then they are developing edges among them also. So this is definitely a case of foci closure. Now if we now is this a case of membership closure as well? So if you see that membership closure basically means that if two people are friends, and if two people are friends and they have let's say one of them is a member of RCC, so the other will also move towards becoming a member. So this is the case of membership closure. So if you see in this case, in this graph, so if you consider this node, so if you see that here these four nodes, you see that they first they become friends, and there is also an edge from these nodes to the foci. So this can also be a case of membership closure. So foci closure and membership closure, this might have resulted in the following network. So we are not sure how it happened, but these are the possible two types of closures that you can see from this network. Okay, so after that, we come to question 10. Question 10 says that given the homophily in a network consisting of class A and class B is very high, that is greater than half, choose the correct option. Again, to recap, so you have class A and you have class B. So you have nodes. What this means, high homophily means that they are well connected among themselves rather than across. So you have some network and there are only, let's say, few edges across. So if you read this option, so across edges are low in proportion, so right, it means high homophily. People tend to make friends within their group, right? In high homophily cases, that is the definition. So birds of same feather flock together. Option 3, the probability of selecting an across edge is low because across edges are low in number and people tend to make friends outside the group. So this is not right. So right answer is D. If you have any question, you can ask. So these were the
Greater than half means.
greater than half means high homophily. So it so homophily, if you see the scale, it can be negative as well. So if this is half, if you go this side, it is low, means they are not connected among themselves, and if you go this side, it means high. So they are more connected among themselves than across themselves. Okay, someone is asking for question 1. Okay, so question 1 asks, Rahul became friends with Ram. Ram is a avid follower of cricket. Ram repeatedly took Rahul to watch cricket matches with him, and soon Rahul started following cricket. So which of the following accurately represents the following phenomenon? So what happened? The right answer is option C, social influence. So Rahul and Ram are first friends, and then Ram influences Rahul by taking him to cricket matches, and then Rahul becomes a cricket fan. So that is a case of social influence. So option C is the correct answer. Is that clear? Question 2. Okay. So, question 2, it says that Ram and Sham are two new entrants in KV Ropar. Their similarity measure was 0.005. They became friends on day 5. what is the most likely similarity measure right before they become friends? So before discussing the solution, so what is similarity measure? It is a number between 0 and 1 to identify how similar two people are, how much common interest they have in each other. So 0 means they are no similarity, and 1 means full similarity. So they have everything in common, and 0 means nothing in common. So so initially they had 0.005 and then they became friends. Now from observation, it is seen that we become friends when similarity increases. So we become friends with people with whom we can see there is a rising similarity with them. So therefore the similarity after becoming friends, right before what, like just near to becoming friends, it must be greater than 0.005, and we know it is less than 1. So which of these four options satisfy that criteria, that is greater than 0.005 and less than 1? So option D is the only one that satisfies. So D is the right answer, 0.01.
Why not option A?
Option is less than 0.05. So their similarity actually reduced. It would, if option A was
Okay.
uh, correct, then it means that their similarity was going down and then they became friends, which is not usually observed. So they are
Then it
asking of
must be 0.005 or 1
no between
in between.
something. Yeah. So it would be similarity S should be greater than 0.005 and less than 1. So this option D is the only one that satisfies that. Okay, any more questions you have, you can ask. If you missed any questions. Question 3. Okay, someone is asking about question 3. Question 3 is saying that on an IT campus, we observed that friendships among first year and second year students are greater than friendship within first year and second year students combined. What can we infer about the homophilia of the network? So you have this first year student and second year student. So homophilia is a measure of connectedness within a group or community. So F11 denotes edges within year 1. So first year. F22 same year 2, and F12 is edges between 1 and 2. So if you consider this F11, F12 and F22, so what is the probability of selecting an across edge? So probability of select number of across edge presents are F12, and the probability of selecting it is uh, the denominator is the all possible number of edges that are present. That's F11 plus F12 plus F22. So this is, let's say, P. Now we know, we have been told that this inequality holds, that F11 plus F22 is less than F12 because it is given that uh, the friendships among first year and second year students are greater than within first year and second year and combined. So combined is the key word here. So that gives us this inequality, which means that if we add F12 on both sides, it's F12 plus F22 plus F1, F11 plus F22 plus F12 would be less than twice F12. If you take the reciprocal, the inequality sign changes. We have 1 over F11 plus F22 plus F12 greater than 1 over twice F12, and if we multiply the numerator with F12, we get that this quantity is greater than F12 over 2 F12, that is greater than half. So we called this as P. So P is greater than half, and homophily is nothing but 1 minus P, which is less than 1. So P is greater than half. So minus P will be less than minus half, and 1 minus P would be less than 1 minus half, that is half. So homophily is less than zero point 0.5. So the answer is option D. Okay, so someone is asking about changing this official time. So actually, I am not responsible for setting the time. The NPTEL coordinators are responsible for the time. However, these lectures will are recorded and will be available on YouTube as well. So you can check the course web page where the link to the videos are given, and you can check the recorded content. So I don't think the time can be changed right now.
Okay, sir. Thank you. No
Uh,
issue. Are you listening me?
Yeah, yeah, I can hear you.
Yeah. Okay, sir. No issue. I have some timing issue. I am just reaching at my home.
Okay, no problem. You
Yeah.
can check the YouTube video. The same thing would be posted on YouTube. The links are given in the course web page. If you go down here, tutorial session links are given. You can check the video over there of whatever we discussed in this session.
Can you share these solved questions, sir, in a chat window?
Yeah, so we give the link to the entire this worksheet that with the solution. It would be uploaded in the course web page as well. You can check the course web page, and here you'll find a Google sheet where the link to the YouTube video is also given, and this solution sheet is also given in a PDF format.
Okay, sir. Thank you. But I have checked in assignment number 4, week number 4. There is some unrelevant solution of those questions.
So okay, so it was
Question number
when
5 to 10. There is no correlation solution of those questions
question
as
5 to
I
10.
have checked, sir.
Oh, okay. So I'll upload it today itself. So whatever solutions I have done so far, so this 10 questions I'll upload it within an hour. So you can check it then. I don't know who posted the other solution over there. So I'll immediately post this solution. You can check that out. In the Google Sheet,
Yeah,
it will be present.
yeah. Okay, sir. And I have one more question also, sir. I want to just know the major differences between homophily and heterophily in intra-community and inter-community.
So in he- homophily is basically the communities are well connected. So if you can see this graph, so a high homophily indicates that the BTech students are well connected among themselves, and the PhD students are well connected among themselves. However, uh, if this indicates high homophily, so homophily means homo. The word homo stands for same. So and phily means liking something. So the same people like same kind of people. So it's like
Yeah,
that bird of
with
same
same
feather.
interest.
Yeah, so
Yeah,
it high homophily would signify that people belonging to the same community have more intra edges compared to inter edges, and heterophily is just the opposite of homophily. So it means that there are more inter edges compared to intra edges. So the people are not connected within the community as such as much as there is connection across the community. So that is meant as heterophily.
yeah. Okay. Thanks, sir. Thanks.
Okay.
And can you tell us, sir, final examination pattern? There
Uh,
will be objective type.
Uh, I don't set the actual question, so I have no idea actually how the final exam pattern will be, because I have only been given the task of solving this assignment question. So you can mail to the NPTEL coordinators, they in the course web page, so they can tell you a better, give a better idea of how the exam pattern will be. I really don't know how the exam pattern will be.
Okay, okay, fine, sir. Fine, fine.
Okay.
Thanks a lot, sir. Thanks a lot.
Yeah.
Yeah, go
Okay.
ahead, sir. Go ahead. Thank you.
Yeah.
Thank you.
Yeah. Yeah. So if anyone has any other questions, you can ask. So someone was asking about the PDF of the question. So yeah, we'll immediately share the this PDF that you can see on the screen. So I'll post it in the course web page. You can see, check it out from there. Someone is asking about question 9. So question 9. Okay, so question 9 is saying that if nodes represent players and edges between players represent friendship, then which of the following phenomenon might have resulted in the following network? So so you have this graph of the Royal Cricket Club. So what could have happened is you have four scenarios: foci closure, social influence, selection, membership closure. So everyone in this graph belong to the Royal Cricket Club, the all the red nodes. Now you can see that if you see, check option 2 and 3, we cannot comment on whether social influence worked or selection worked, because we do not know what the similarity measure was. So this graph doesn't give you any idea of what the similarity measure is. So we cannot tell that whether it's social influence or selection. But if you check any uh, two people in the graph, so any two people, it's a connected graph first of all. So they became friends because they belong to the any, let's say, consider this 1 and 2, there is an edge between them, so they are friends. So it could be and they both belong to the Royal Cricket Club. So it could be that this edge exists because this friendship developed between 1 and 2 because they were both going to the Royal Cricket Club. So this is a case of foci closure. So this is a possibility. So they just asked that. So they asked which of the following phenomenon might have resulted. So not exactly resulted, but might have. So which are the possibilities? So it could be foci closure, that they came to the same place and then they became, and also it could be a membership closure, because let's say you consider this between, let's say here 3 and 4. So it could be that 3 and 4 were friends previously. So it was 3 and 4, they were previously friends, and 3 started attending RCC, the Royal Cricket Club, and then 4 also became a part of RCC. So this is membership closure. It could happen. So this is also a possibility. So we have included 1 and 4. So both of them are the correct answer. So 1 and 4 both are the possibilities that could have happened here. Okay. So this was question 9. So if you have any more doubts, you can ask. Okay, someone is asking for question 7. So 7 is basically is asking, Ram and Raghav both are friends in the Royal Cricketing Club. They meet at the club and gradually become friends. This phenomenon is known as. So the right option is foci closure. So what's happening is that initially Ram and Raghav were not friends, but Ram and Raghav both went to this Royal Cricketing Club, so RCC, and then they developed friendship among them. So this dotted line denotes that they are becoming friends. So this is a case of Foshai closure. So this RCC is their common focus. So they met at a common focus and then developed friendship. So this is option C is the correct answer. Okay, are there any more questions? Yes, someone is asking about sharing these questions. Okay, I'll send you these questions on the email address that you have given. Someone is asking about how much assignment counted out of 12 in case we are missing any assignments, sir. So I really don't know about this. So you'll have to inquire with the course coordinators. You can write a mail to them, they will know. I have only been given the task of taking these tutorial sessions.
Sir, have you NPTEL WhatsApp group right now?
No, I don't know if such a group exists.
Okay,
I'll
but
send you on the email ID that you have provided. I'll send you the materials. Don't worry. I'll
yeah,
send you the video links also.
okay, sir. Thank you.
Yeah.
As I think there should be no issue if you can share, sir, in a chat window in MS Team. You can share if
Okay.
you have no.
Okay. Just wait on a minute. Let me check.
Yeah, as I think there should be no issue, sir.
So,
So that all student may access easily all things. I am
uh,
also faculty in MIT University Noida, Computer Science Engineering Department, sir.
okay.
And
Okay. So,
this is my additional subject, and my student who are doing research in these areas.
okay. So I
Yeah.
have shared a document in the chat window, if you can see. So this document, if you click on this document, you have the links to the YouTube video, and there is a presentation folder. So if you click on the presentation folder, you get access to all the lecture materials, the PDF versions of what I have just presented. So I'll upload the week 4 in an hour, but you can check for the previous weeks as well, which are given in these links. You can check it out and tell me if there is any problem. So the first set of links belong to mine, and the second set of links belong to the other TA for the course.
Yeah, it's working, sir.
Okay, yeah, I'll upload week 4 also today. You can check
Yeah,
after an hour, you will find it there.
yeah.
Okay, so if anyone else has any question, you can ask. Then, if no one has a question, we can close the session for today, and tomorrow again the tutorial session will discuss week 5 questions.
Tomorrow also, sir.
Yeah, tomorrow
There-
from 6 to 7, you will get an email notification. So from 6 to 7 there is another tutorial session taken by the other TA who will be discussing week 5 questions. So I discussed week 4 questions today.
Yeah.
So
And
to yeah, go ahead.
for time changing, sir. For time changing, where I sent to mail.
You send directly to NPTEL. So there is a link in the NPTEL website, I think, for you mention this course name NPTEL @IITM@ac.in, I think, and you check
Yeah.
the course web page, you will find a contact detail, and there you mention this course number, that is the course ID which is given, and you tell that you want to change the time of this tutorial session. So if you send it, they might reply to you. Yeah.
Okay. Thanks, sir.
Yeah, the someone is asking is everyday time is same, so it's only on Monday and Tuesday, and coincidentally the time is same from 6 to 7. So this happened by coincidence. You can ask them to change
But
it
in
as well.
NPTEL group timing is mentioned there 6 to 8 p.m., sir.
Yeah, 6 to 8. So usually people after 7 people don't have any questions, and so we close the session. So if anyone has a question, we can continue up to 8. Otherwise, I have finished all the questions to that I plan to discuss this session. So I'm happy to stay till 8, but if you don't have any question, we can close the session.
Okay. Thanks a lot, sir. Thanks.
Yeah. All right then. So if you still have any question, you can type it in the chat box, or you can ask now, or then, or else we can close the session for the day, and again we'll meet next week to discuss week 5.
Hello.
Yeah, go ahead.
Sir, can we discuss live assignment question or old assignment question?
Yeah, so we are not discussing this live this year's question because it is for you to solve. So if we give the solutions already, then you won't learn anything. So it is, we'll solve you for you the previous year's question, and you'll get an idea of how to solve this year's question. So this year's questions are for you to solve. We won't give the solution as of yet. So at the end you will get, means after submission of the assignments, you will get the solutions yourself, but we won't discuss it in this tutorial sessions.
Okay, so that question also sometime matching, I think.
Yeah, then like then that is okay, but we will not explicitly pick questions from this year's assignment. So these questions are picked from last year's assignment. So if they are similar, then all right, it's lucky for you, but we don't pick questions from this year's explicitly.
Okay, okay, okay.
Yeah.
Sir, I was sharing my mail ID. Any like notes and all available, then send it.
Yeah, I have shared this Google document in the chat window.
That
You can
cover
see.
all points. Okay, okay, okay.
Yeah, so it has all the links to the lectures and the YouTube videos as well. you can check it out.
Okay, sir. Thank you.
Yeah, yeah. Any more questions?
No, sir.
All right, then I think we can close the session for today since none of you have any further questions. So, okay. Thanks for attending and all the best for the course. I hope everyone will do well. So we'll meet again next week. So, bye.
Yes, thank you, sir.